Vanakkam friends, Dr. Vanangamdi welcomes you all to Trinity Cultural Academy. Again, I am stressing this point to study soil science very strongly because many questions may arise in examinations. Maybe 30 to 35 questions may appear in competitive examinations. In this presentation, we will discuss about the next 4 soil physical properties like soil density, porosity, temperature and air. In soil density, the first one is particle density, which is also known as true density. It refers to weight per unit volume of solid portion of soil. Normal soil has particle density of 2.65 gram per cubic centimeter. Particle density is higher in soils containing heavy minerals like magnetite, limonite, and hematite. Increase in organic matter in the soil results in decreased particle density. Next important one and frequently asked part in examination is bulk density. It is defined as the woven dry weight of per unit volume inclusive of pore space. Generally, bulk density is smaller than particle density. For sandy soil, it's about 1.6 gram per centimeter cube or cubic centimeter, while clay soil is about 1.1 gram per cubic centimeter, and the organic matter has bulk density of about 0.5 gram per cubic centimeter. Low bulk density favors for better physical conditions of the soil. Next, we discuss about the factors that are affecting bulk density. They are texture, organic matter content and pore space. Regarding soil texture, silty loam, clay loam and clay soils have lower bulk density compared to sandy soil. Higher the organic matter, higher the pore space. In turn, it shows the low bulk density. Higher pore space results in low bulk density and vice versa. Let us now discuss the another physical property of soil, which is porosity. What do you mean by porosity? It is part of soil volume not occupied by soil particles and organic matter. It is the space occupied by air and water. In sandy soils, pore space is low because soil particles are arranged very closely, while in clay soil it is high due to porous arrangement of soil particles. More the organic matter content, higher the pore space. Next, we will see the factors that are influencing pore space. First factor is soil texture. Sandy surface soil has a pore space of 35 to 50%, while medium and fine textured soil records 50 to 60%, which is higher compared to compact subsoil, and this contains 25 to 30% pore space. Coming to crop and vegetation, planting bluegrass increases porosity from 50% to 57.2%. Virgin soils have more pore space. However, continuous cropping reduces pore space and more crops per year also reduces pore space. Conservation tillage reduces porosity compared to conventional tillage. There are two types of pores. First one is macropores, and it is non-capillary pores having more than 0.05 mm diameter, whereas micropores are capillary pores which have a diameter of less than 0.05 mm. Because of gravitation and mass flow in macropores, air and water moves freely while their movement is slow and restricted due to capillary movement and diffusion. Sandy soils have more macrospores when compared to clay soil, which has more micropores, whereas porosity of loamy soil is 50%, and in that there are equal number of both pores. Next physical property of soil is soil temperature. Soil temperature directly affects the growth, while it is having indirect effect with respect to soil moisture, aeration, structure, microbial and enzyme activities, rate of organic matter decomposition, nutrient availability and chemical reactions. Coming to sources of heat, two sources, namely external and internal, solar radiation and heat released by microbial decomposition of organic matter and respiration of microorganisms are external heats, while internal heat are interior of Earth. What do you mean by solar constant? It is the rate of solar radiation reaching Earth's atmosphere is solar constant, and the value is 2 calories per centimeter square per minute. Let me now talk on factors that are affecting soil temperature. First factor is environmental factors. Annual soil temperature is always 1 degree Celsius higher than annual air temperature. Heat received from sun is about 2 calories per centimeter square per minute. Heat transmission depends upon the incident radiation, latitude, season, time of the day, direction of slope and latitude. Second major factor is soil factors. Thermal or heat capacity of soil, and that means amount of energy needed to raise temperature by 1 degree Celsius. Specific heat is called when it is expressed as per unit mass, that is calories per gram. Specific heat of soil is 0.2 calories per gram and water is 1 calories per gram. Then heat of vaporization, energy of 550 kilocalories per kilogram of soil is needed for water evaporation from soil. The thermal conductivity and diffusivity refers to heat movement in soil through conduction. Thermal conductivity of soil forming material is 0.005 units while air is 0.00005 units and water is 0.001 units. Biological activity, namely respiration by microbes, animals and plant roots also evolve heat. Radiation from soil is long waves and that is 0.3 to 2.2 microns, while from sun is short waves. Soil color produced due to reflection of radiation of specific wavelength. Dark colored soil radiates less heat than light colored soil. Larger the albedo, cooler the soil. Albedo means the ratio between reflected energy, that is outgoing energy, to incident energy, that is incoming energy. Next factor is soil structure, texture and moisture. Compact soils having high thermal conductivity than loose soil. Mineral soils have higher conductivity than organic soil. Finally, soluble salt. It is indirectly affects soil temperature by microbial activities and respiration. How to manage soil temperature? By use of organic and synthetic mulches, soil water management and tillage management. Mulches keep soil cooler in summer. High moisture reduces heat. Tilling helps in heat loss. Next we see about how to determine the soil moisture. By use of mercury soil thermometers, infrared thermometer which records surface soil temperature, automatic continuous soil thermograph records soil temperature on time scale. IMO, International Meteorological Organization, recommends standard depths of 10, 20, 50 and 100 cm for measuring soil temperature. Last soil factor is soil air. It is a constant movement of air from pore space to atmosphere and vice versa. What is soil aeration? It is renewal of air and its gaseous component into the soil from atmosphere. Soil air contains less nitrogen and oxygen than atmospheric air, but carbon dioxide is higher in soil air than atmospheric air. We discuss about few factors that affecting soil air. They are nature and condition of soil, type of crop, microbial activity, seasonal variation and temperature. Light textured or sandy soil contains high air than heavy soil. Soils with crops have more air than fallow soil. Decomposition of organic matter produces more carbon dioxide. High temperature encourages high microbial activity which results in high carbon dioxide release. Then we discuss about causes of poor aeration. Excess moisture due to waterlogged and flooded condition develop poor aeration. Poor aeration of this type is eliminated by removal of excess water through proper drainage or control of runoff. Gases interchange between soil and atmosphere depend on rate of biochemical reactions influencing soil gases and the actual rate at which gas is moving into and out of soil. Coming to methods by which gases exchange takes place between soil and atmosphere, there are two methods. Method 1 is mass flow. Rain and irrigation helps to move soil air to atmosphere. Evaporation and transpiration helps in the entry of air to soil pore spaces. Second method is diffusion. By diffusion, oxygen and carbon dioxide diffuses into soil from atmosphere till equilibrium is established. Last part of this session is importance of soil aeration. Importances are plant and root growth, microbial population and its activities, formation of toxic materials, water and nutrient absorption, and development of plant diseases. For healthy plant growth, adequate soil oxygen and removal of carbon dioxide are must. Oxygen deficiency slows down the microbial activity and decomposition of organic matter. Toxins like ferrous oxide, hydrogen sulfide, and carbon dioxide are accumulated in soil due to poor aeration. Plant also exhibit water stress and nutrient deficiency. Wilt of gram and dieback of citrus and peach are typical symptoms of poor aeration. Let us now see about questions and answers. Solar radiation reaching the Earth's atmosphere is option C, 2 calories per centimeter square per minute. The percentage of carbon dioxide content in soil air is about option C, 0.30 percentage. The bulk density is low for option D, clay soil. Pore space is higher in option B, clay soil. Coming to one-liners, particle density is also called as true density. Particle density of normal soil is 2.65 gram per centimeter cube. Woven dry weight of unit volume of soil inclusive of pore spaces is termed as bulk density. Bulk density of clay soil is about 1.1 gram per cubic centimeter. Space occupied by air and water in the soil is pore space. Pore space is high for clay soils. Value of solar constant is about 2 calories per centimeter square per minute. Friends, the presentation is over. For PDF and online test, text me at 9894904745 or mail me at vanangamdi.tnau@gmail.com. Friends, kindly subscribe my channel to get upcoming videos. Thank you very much.